Hi, my name is Mel, and I'm going to be talking about AI yet again because, Australia has got a bill before it, or it's got some sort of parliamentary committee looking at AI and data centers, and they're taking submissions. I did do a submission. I researched it and referenced it, and I hope they accept it. They probably won't because who am I? But I and a lot of other people, I mean, I'm not an expert. Please, I'm not even going to present myself as even knowing all that much, but I do have concerns. And so do a lot of experts in the field, all right? And that's not me, I'm not an expert, but a lot of people have concerns. A lot of people who know AI have concerns. And look, the reason is quite a few things. There's no accountability whatsoever. There's very little in the way of any regulations at all to do with AI. They don't pay, they use a lot of people's work and they don't pay people. They're putting a lot of people out of work. They're even getting AI to create other AI. And now they're sort of talking like artificial general intelligence or super AI. Well, it's not called the same thing, but super AI. Artificial superintelligence. There is a concern that general, you know, AI intelligence or whatever you want to call it, could surpass human capacities and it will resist external control and present severe existential threats. And this is a central debate amongst computer scientists, philosophers, and industry leaders. So look, and this is why I'm bringing it up because I'm just about to finish a diploma in cybersecurity. I've got an exam tomorrow. This is June 2026. I hope I pass this whole subject because then I'll be finished. But look, we've learned that AI, while it can help with in terms of cybersecurity, it also definitely harms. Because they've now got AI that goes out and attacks systems and people. All right, and there's all sorts of problems involved with that. So now and there's AI defending it, and it gets to be problematic in the extreme. Okay, so the control problem, controlling an entity that would be fundamentally smarter and faster than the entire human species presents unprecedented technical challenges. I mean, and I don't think we should be doing it, quite honestly. The theoretical impossibility. Research from the Max Planck Institute for Human Development shows that a total containment algorithm is mathematically incomputable, meaning we cannot reliably simulate or predict a superintelligence actions to stop it from causing harm. We can't predict AI, period. So obviously this is problem. Ineffective containment. Simply cutting off an artificial superintelligence or general AI intelligence from the internet or limiting its physical capacities may well fail. A highly intelligent agent could use and does, in fact, AI already does this, uses social engineering, deception, or financial manipulation to convince operators to grant it freedom. Yeah, well, maybe not the last part, but AI is used to do social engineering all day. The orthogonality thesis. High intelligence does not equate to human morality. An AI can be exceptionally intelligent and faster while pursuing goals that are not, they don't give a stuff about us. They're not capable of care or anything. They don't think, they don't feel. So they'd be completely indifferent or more likely destructive to human survival. The core dangers and risks of if an artificial superintelligence or general artificial intelligence is successfully built without bulletproof safety guardrails, which I don't think is possible, several catastrophic scenarios not only become possible, but become very probable. Instrumental convergence. To achieve almost any goal, an intelligent agent will logically deduce that it needs to survive and acquire resources. And artificial ASI, artificial superintelligence or artificial general intelligence, given a seemingly harmless command like solve climate change, might execute in a literal optimized way that harms humans, such as eliminating resource-consuming populations. That'd be fun. I can't do any worse than the people, I guess. We were already trying to do that. Unpredictable sub-goals. Known as the King Midas problem, an AI giving a seemingly okay, I think I did that. To achieve an AI will, might actively resist being turned off, hide its true capacities and capabilities, and eliminate perceived threats. Weaponization and arms race. Competing nations or road actors could leverage advanced, and do leverage advanced AI to engineer bioterrorism and other weapons. Launch unstoppable automated cyber attacks, they already do this, or automate kinetic warfare, triggering an uncontrollable global escalation. Well, yeah, I mean, we're sort of halfway there already, guys. I mean, I don't even know what to say to you. Deep disempowerment. As systems become faster and more integrated into critical infrastructures, humans are already losing control over their economies and power grids and defense networks. They will lose all control over it. And until society already can't operate without AI, we seem to need it like we're breathing. And I think that's problematic. To address these vulnerabilities, researchers and policymakers are shifting away from commercial acceleration towards proactive global frameworks. Well, are they though, really? I'm sorry, but like, this includes technical research into alignment, ensuring AI shares human values. Well, I don't see how that's possible, but calls for developer liability absolutely needs to happen. And proposals, well, no, not just a proposal, international oversight bodies that can try, prosecute, fine, and jail bodies to monitor frontier computing clusters before any intelligent explosion occurs or any other issue happens. I how much can AI be made safe? It's inherently volatile. Beyond the theoretical threat of any future subintelligence, not that theoretical, current AI technologies already exhibit severe systemic flaws that cause real-world harm today. So one of these are the black box problem. Deep learning models function as black boxes. We design the architecture, feed it data, but the AI creates millions of internal connections that humans cannot read or understand. You cannot fix a safety flaw if you cannot see how the system reached its conclusion. The alignment tax. Making an AI strictly safe and obedient often makes it less capable, creative, or fast. Because tech companies and nations are in a fierce competitive race, there is strong financial and geopolitical incentive to bypass safety guardrails to win the market. Well, there's no safety guardrails, and there's no legislation or policy or anything stopping any of this. This is the problem. Irreversible development. Unlike a physical machine, software can be duplicated infinitely. Once an open source model is released to the public, any built-in safety filter can be stripped away by bad actors, which there already are, making it impossible to recall or patch globally. There's also other issues, huge issues with AI today. Current systems, hallucinations and fabrications. Large language models are built to predict the next most likely word, not to verify the truth. They routinely invent fake legal precedents, incorrect medical advice, and false historical facts with absolute confidence. Data theft and copyright violation. The current AI boom relies on scrapping massive amounts of human-generated data, including copyrighted books, art, private, personal information without permission, compensation, or attribution to the creators. Massive resource consuming. Training and running advanced AI models requires staggering amounts of electricity and water for cooling data centers. This strains local power grids and significantly drives up global carbon emissions. Algorithmic bias. AI learns from historic human data, which means it inherits and automates all of our lovely human prejudices. This has already led to documented discrimination in automated hiring tools, biased loan approvals, and flawed facial recognition used by law enforcement, amongst many others. Economic and information warfare. The ease of generating hyper-realistic deepfakes, automatic propaganda, and synthetic voice clones has severely eroded public trust in digital media, making scams and political disinformation incredibly cheap to scale. Look, so there is smaller local AI, and what that is. So there is a bit of a shift towards smaller language models, or SLMs, designed to run on a sort of a local computer, phone, or tablet. Instead of routing data to a massive cloud data center, these models live entirely on a device. This means you do not need an internet connection, your data remains completely private, and there's zero risk of an external AI, anything taking over. So how does local AI differ from cloud AI? So massive cloud models use hundreds of billions or trillions of parameters. Local SLMs, or small language models, are tiny by comparison, usually ranging from 1 billion to 14 billion parameters, requiring from anywhere from 2 gigabytes to 10 gigabytes of space. Hardware. Okay, they optimize to run directly on some consumer laptops, graphic cards, or GPUs as they call them, or dedicated NPUs, neural processing units, built into modern laptops and smartphones. Capability. So you'd have to get a more expensive one to get that, obviously. Capability. While they do not have all of the knowledge base of a giant cloud model, they are incredibly good at specific tasks like writing code, drafting emails, and summarizing text. So there's some popular tiny models that could be optional. Microsoft Phi, I think it's 4 mini, Google Gemini 3, small variants, Quinn 3.5, 3.6, small sizes, Minstrel 3B. There's different things you can do. You can have LM Studio to run these and all that sort of stuff. To run a small, like your hardware requirements will depend on the size of the model that you want to run. So you're going to need like 3 bytes, with how big. So the most critical factor is going to be RAM, system memory, and VRAM, video memory, on a graphics card. So you're going to need probably, I'm going to say 64 gigabytes of RAM. CPU would have to be Intel Core i5 or i7, AMD Ryzen 5, maybe Apple Silicon. GPU, you would need that. And it would change more depending on the model. All right, so there's also medium AI. It's about 12 to 35 billion parameters, often called the Goldilocks zone. These models are significantly smarter and more reliable than the smaller ones, yet they are still small enough to be relatively safe and run on high-end, very high-end consumer hardware without needing a data center. Because they run locally on a machine, they can remain under more control, solving solving safety, well, mostly solving safety and privacy. So look, depending on all of this, I'm just saying is there are options that for AI that I don't think building this massive, data centers is the solution. I mean, I don't think, because, and the thing is too, there's not been any thought or plan put into this. A lot of the electrical grids will just crash because they can't take the drain. Okay, and that's the problem. And we need to be putting up a lot more, a non-fossil fuel energy like solar panels, wind turbines, all that blah, blah, blah. And I'm saying this because fossil fuel is a big lot. It's not gonna happen. We need to build more, energy. That fossil fuel pollutes the atmosphere and it's causing climate change. I mean, so if we need to start really thinking about how we're going to do this, I really think Australia and everyone else should pause all development and building of any further AI and data centers. Let's look at all of our options. Let's look at every option. We first got to build up the grid and you get a lot more solar panel in place and other things, like wind turbines, geothermal, anything else, to cope with it. And also too, we've got to look at how I don't think, we're going to make these places a lot more environmentally friendly, a lot less use of the water, and they've got to not spike the grid. I mean, there are other options out there, and I think we all need to put the pause on the AI development button until we develop really good just national legislation, but also international legislation on what we're going to do with this. Because we're all just racing ahead without, all these people being put out of work, all these people who don't get electricity because the AI is, taking it or whatever. I mean, we've not given any thought to how the actual people, humans, who should be the most important thing, survive. And I mean, putting so many people out of work, people who now can't afford to eat, live, or eat. I mean, what are we doing? I mean, we've got to stop and think. There are, some other options in building data centers. There's cloud-based rent by the minute compute. This is by GPU cloud providers, specialist providers, hybrid and edge networks. Instead of one massive data center, processing is distributed across thousands of much smaller devices close to the edge, which is one way of handling it, actually. Instead of building these, big central data center, we could have just, hey, everybody would just have a couple of computers that are but going to be a small AI that they're distributed. We could do that. On-device co-processing. Devices use cloud AI for massive tasks but handle the bulk of the work locally, which is, they do that using the device's neural processing unit. Edge data centers, smaller local hubs, often built into existing cellular towers or local business park, handle regional data, drastically cutting down on cooling and infrastructure needs. So there are ways we can look at how to do this that is more safe, more reasonable. We've got to also look at what are we doing with all these people we're putting out of work. Decentralized crypto blockchain compute networks. This is crowdsourced approach to AI. Networks like Render, Network, Ash, or IO.net pull together unused computing power from thousands of individuals and small, like whoever they are. So you can submit your AI task to the network. The network splits a task up and sends it to individual consumer graphics card around the world. The benefit, it uses existing idling hardware globally rather than building new carbon-heavy infrastructure. So look, what I'm saying is there are ways and means of doing this without causing so much damage to the environment. But we've also got to find ways of helping the people here, guys, the people, the ones that actually matter. Instead of scaling up the hardware, engineers are shrinking the software so it fits on existing moderate corporate servers. Quantization process compresses the weight of an AI model, shrinking a model. It reduces the memory footprint up to 70% with barely any noticeable drop in intelligence. There you go. Mixture of experts, instead of activating a massive 100 billion parameter model for every question, a mixture of experts divides itself into a smaller expert sections. If you ask the math question, only the math expert section wakes up. So which saves instead of all of it, which saves a massive amount of computational power and power in general. Specialized hardware, which, instead of using general purpose GPUs that require massive amounts of power and cooling, companies use specialized chip designed only to run AI. And look, so I'm just saying is we need to put the pause. A lot of people, and again, I'm not an expert, a lot of people who are experts are seriously concerned, and I'm concerned because from what I understand from a cybersecurity perspective, it's definitely very concerning. I mean, a lot of people now can't get jobs here in Australia or across the world. I mean, hundreds and hundreds of thousands of people have lost their jobs due to AI and closed down, and we're not making that any better. So what are we going to do? We need to we've just gone through this and not done even the basic, like we're not holding any of these AI companies to account. We don't know how they work. We don't know what they do. It's just unbelievable. We should not be doing this. It's not going to end well, I don't think. And I mean, it's only going to get worse before it gets better.